Hello class. In this lecture we will be discussing matter and kinetic molecular theory, aka the universe is one big ball pit. For today's topics we'll be discussing matter, kinetic molecular theory, and physical states. All of these have their own subtopics which we will get into as well. So to start with matter. Merriam-Webster defines matter as a material substance that occupies space, has mass, and is composed predominantly of atoms consisting of protons, neutrons, and electrons that constitutes the observable universe and that is interconvertible with energy. What this means is that a lot of it is true, all of it is true. However, for today, what we care about is that matter occupies space, matter has mass, and that matter constitutes the observable universe, aka everything. Matter is made up of literal little sphere building blocks called atoms. Matter takes up space and has a mass. So what are atoms? Atoms are the fundamental building blocks of everything. For now, I want you to know these things about them, which are that they are incredibly small, they compose everything, and their behavior is the core of chemistry. They are also your friends. I mean that in a funny way, but also your friends are made out of atoms. Here is an example of one. There's a lot of little pieces to it, but for now, all you need to know is that it makes a little sphere, which would look like this. This is a high-resolution electron microscope image of a bunch of atoms. This is not a picture because a picture cannot be taken. A picture uses light. It's not a photograph. However, you can see these little spheres are atoms, and these little black voids are literally that. There's nothing there. This is a picture this image is not relevant to this class. I just think it's an advanced concept. I think a cool advanced concept, I should say. So the reason I say that this is the ball pit lecture is because I really think it's easier to think about the world as a really big ball pit. If every single one of these things is a specific substance, all the atoms that are the same are going to be the same colors, and all the ones that are different are going to be different atoms. And where they mix, that's where their behavior is. Matter is trillions of little balls in a universal ball pit. Energy. So now let's talk about energy. All matter has energy. Matter can absorb or release energy as needed or as it experiences it, and energy of matter dictates their behavior. So you could pretend that this atom is violently shaking, and you got it right. Along with that, your atom moves through space. This is called kinetic energy and is literally the energy of movement. Disclaimer, we will discuss energy more in its own section. So bring all that together, atoms and energy. If matter is our building blocks and energy is how they move, chemistry is how bringing that together, let me repeat that. Matter is our building blocks. Energy is how they move. Chemistry is our understanding of how those two things interplay. So then we move on to conservation of mass. So matter cannot be created or destroyed. It may only change shapes, which is important to us because it allows us to understand a lot of things in the real world. For example, if you have a fire log, set it on fire, and walk away for several hours, you'll come back to a pile of ash. This pile of ash will be smaller than your logs, and you might think, oh, well, you can see that we destroyed mass. No, what happened was that your logs became gas, and the gas spread everywhere, and that's your new mass. The gas just left the area. An ice cube. You drop an ice cube on the asphalt on a 100-degree day, in a few minutes, it'll be gone. That doesn't mean that the ice cube was destroyed. It just means that it became water and evaporated and left. Okay, so can we formalize all of this? Yes. We want to be able to explain chemical behavior based on its energy and matter, which we can do using kinetic molecular theory. So what's kinetic molecular theory? So we know all mass has energy. We know all mass is made of little spheres known as atoms, and we want to make a model that brings it together. So the type of energy that atoms have is known as kinetic energy. Atoms are also known as molecules. There's some nuance to this. Every atom is a molecule, but not every molecule is an atom. For now, just think of atoms as molecules. And a model can also be referred to as a theory, which, bring it all together, kinetic molecular theory. So we can use the fact that matter has energy to define and understand its behavior. So for example, before that, let's move into its rules. So there are 4 rules of kinetic molecular theory. The first is that all matter is composed of tiny particles. That's just elements, atoms. These particles are in constant motion, which is their energy. It's always going up and down. The amount of motion is proportional to temperature. Increased temperature means increased motion. We will cover this more in energy, but temperature is a direct reflection of energy in the system, and the system being wherever you're at. Lastly, solids, liquids, and gases differ in their freedom of motion of their particles and the extent to which these particles interact. What this means is that as your particles get faster, they move around more, they have more freedom, and this affects what type of particles they are. We'll get into that in a second as well. So, what does it mean to have mass? Mass is a measure of how many molecules you have, so it's simple. If you have 1 molecule, you have mass. If you have 4 molecules, you have 4 times the mass. Your mass will never change. It is a direct measure of how many molecules you have. Next up, weight. So weight is different. While an object's mass is a measure of how much of it there is and does not change, weight does change. An object's weight is a measure of how much force it presses against the earth or whatever object it's on and is affected by gravity and distance. The way that I like to explain it is with this diagram. If you take a person on Earth's gravity, they will weigh 490 newtons. But if you send them to the moon, they will only weigh 80 newtons. However, their mass will be the same. Their mass will not change at all. Temperature. What does it mean to have temperature? Well, temperature is a measure of how fast the atoms of a system are moving, aka how much energy there is in your system. So if your atoms are moving very fast, they have more energy, therefore they are hotter. A lump of hot matter and a lump of cold matter will have the same amount of matter, but be different in the speed that their particles move. So if this is a cold particle, it would be like this. And if it's the same particle, it might be like this, if it's hot. Hot and cold are just relative measurements of velocity. They don't actually have any real meaning. Like there's nothing bad about things being cold or there's nothing bad about things being hot to the universe. To us, it matters because it affects us directly, but the universe does not care. And neither does this guy. You can see, since temperature is relative, he's going to be outside in a snowstorm wearing shorts. Volume. So volume is the physical space that something takes up. All matter has defined physical space, and it always has a volume. So for example, soda has a volume. You can also define volume without matter. So for example, a fish tank. The space inside of it is technically not matter, it's just space, but it has volume. Materials can have the same mass but different volumes. So for example, you could have 1 kilogram of feathers versus 1 kilogram of titanium, and that has to do with the way that their molecules are spread out. Titanium has molecules that are closer together versus feathers has them that are further apart. Another example of something with volume that I like is the Las Vegas sphere. It's just a really big sphere that is in the middle of town, and it's a circle. It has a volume and it has a mass. It also has a luminous intensity, if you remember that from the metric system class. So, can we use KMT to define further? Yes. So, an object's physical state is affected by how its particles behave, which allows us to really understand it using KMT. So, what does that mean? So, we talked previously about how gas, liquids, and solids are all different materials that are the same material at different temperature. For example, here, water at really low temperature will be solid, whereas at high temperature, it will be steam. An example of a solid material is this brick. This brick is solid because it has its own shape and it can hold it. Versus here, a liquid cannot maintain its shape. Why is that? That's because its particles are moving so fast that they are able to break out and they do not maintain their shape. Gas is the extreme of this. Gas has so much freedom of movement that these particles can end up anywhere. One gas particle here could end up all the way on the other side of the world if it gets lucky and flies in the right direction. Who knows? And sometimes you have all of them, like this bottle of soup. this bowl of soup has solid mass, liquid soup, and steam, which is a gas. Here you can see a breakdown of how molecules behave as they're heated up. So in water, they start solid, compacted together, have their own shape. As they start to melt, they start to lose their shape and become liquidy, take up the shape of their container. Once they're full liquid, they've taken up their container and now they have their shape. Then after that, they start to evaporate. Some of them become gas and escape. And at that point, the little balls have gotten all the way out. Please review this example. I will have it on one of my exams. I have not failed to do this at any point since I became a professor, and I will not start today. So, material properties can be understood using kinetic molecular theory as well. What are material properties? Well, all matter has two types of properties, chemical and physical. A chemical property is a substance's tendency to undergo changes. Example, will this chemical react with another one? This can be measured using KMT, but it's difficult because you have to take two sets of little balls and smash them at each other and see how they'll react. You can still use KMT to describe this, however. Similarly, a physical property is a substance's measurable qualities that do not change based on its quantity. So you only need the KMT for the specific thing that you're working with. So for example, again, this atom. All substances have defined mass and volume, so with KMT, you could look at that as well. If, for example, you're using KMT and you know that your gas is vacuous and takes up space, then you know that that is a physical property. I lied a little bit in that I said that KMT can help us. It can. However, the how is outside of the scope of this lecture, and we will be covering it later. I want you to know today, though, that we have physical properties and chemical properties, and they can be explained with KMT. That brings us to the end of this lecture. Thank you for your time. We'll see you in the next one.